This conference will now be recorded.
Please go ahead.
All right. Yeah. Good morning, everyone. My name is Raja. You can call me Raj also. Just, I want to make my name as stylish because I don't want to look old. So, yeah. So, welcome to the session about Snowflake. Today, we will understand what is the definition of a traditional data warehouse, what are its advantages and disadvantages, capabilities. We'll try to understand what is cloud data warehouse in brief. Then we'll jump into Snowflake and um, its capabilities. So today it's going to be high level kind of discussion because I don't want to get into too much technical details. Let's try to understand the background and the context first, and then we'll jump into the core technical areas, right? So having said that, um, this is the agenda what we have for today's session, and you can feel free to stop me at any point of time if you have questions, or if you wish to take the questions and answers at the end of this presentation, where you're welcome. Right. So as I said, first we will talk about what is a data warehouse, its evolution over the past decades, limitations of traditional data warehouse, what we currently have in some of the organizations, what is a cloud data warehouse and why we need a cloud data warehouse. And then we'll come to the point that what is Snowflake and why we have to go with Snowflake and why not with others, right? So give me a second. How do I hide this thing? Yeah, perfect. Right. So I believe everyone are aware of a data warehouse, how it works and its capabilities. I'm just trying to put, in layman terms, what exactly is a data warehouse, right? So you can read it from the slide itself. And as per Ralph Kimball, so this is subject-oriented, integrated, non-volatile, and time variant, right? So in you can assume a data warehouse as a centralized storage unit, wherein you can bring all the structured data and to a certain extent of semi-structured data. You kind of clean that and then put it in a meaningful way so that the business users and the analysts and then the technical team who wants to leverage the untouched data areas, they can look at it and then they can predict what has been there in the past, what is today, and what can be done, and how we can improvise it with the data. You can see the patterns, you can see the trends, and then you can make some decisions out of it, right? So as I said, as per the theory, it is subject oriented. You can have your sales related data at one place, your finance related data at one place. I mean, when I say one place, it's a centralized place. The meaning of integrated is the very next definition says about it. And then it is non-volatile, meaning in data warehouse, I just cannot simply bring in the data and flush it out. No, I will keep it for some time to make sure I can run some queries for analysis and prediction purpose. And it is time variant. We capture all the changes, versioning everything here in our data warehouse. So let's look at the evolution of data warehouse, how we were and then how we are currently and what are we going to be in next couple of years or decades, right? So it all started with I will not go back beyond 1980s because we will start with the relational database concepts, and because earlier it was even more different way of storing the data. Here in 1980s, we started off with the relational databases. We brought all the data from different places, tried to keep it in tables, and as and when the data started growing, so we started seeing the challenges, like how do we maintain it, how do we index it, how do we partition it, right? how do we improve the performance? Then came in the data warehouse appliances, wherein you bring all your appliance, your server, your storage, your processing unit at one place, and then run your data warehouse on top of it. So even then, it was not meant to handle easily. It had its challenges, like the maintenance and scalability was a big challenge. We'll talk about it how in the next slides, how it looks and when I see the challenges. And then in the 2000, we came up with in on-premises data warehouse, where you have data at, let's say, one node. It has its own storage unit, and then you run your data warehouse on top of it. So the next thing is 2010, where the cloud started, where I mean, it in somewhere between 2000 and 2010, the concept of columnar storage was started. Of course, it was there in 1998 also, but actually it came into full utilization or in the market in 2000. So we started using columnar storage extensively. Then the people thought, okay, why don't we put everything in different machines, like distributed systems, and then put it in a place. We call it as cloud. So then the cloud data warehouse started in 2010s. And in 2010s, what there was a scenario like, okay, we had the data warehouse both on cloud and on premises. In the next gen cloud data warehouse, I called it as next generation because in eventually we will be seeing all the processing, all the data warehouse data, everything on cloud, right? So that's where we call it as next generation, and we hopefully we will. I mean, most of the organization will try to eliminate on-premise applications like ETL server, database, everything will be hosted on cloud instead of on-premise and connecting to cloud. So it's kind of complete cloud data warehouse. Right. So I was talking about the traditional data warehouse and its limitations in the beginning of the session. So let's look at, in theory, what exactly are the limitations, right? The complexity. So it is not exactly suitable, I mean, the traditional data warehouse to accommodate huge volume of data, huge variety of data, right? Structured, unstructured, semi-structured, with different data formats like JSON, XML. It cannot handle that easily, right? And the second point, it covers also like diversity. It's not good enough to handle the diverse data structure, as I said, like JSON, XML, and you have traditional flat files. Of course, you can process it, but you cannot club all the data together. Elasticity, the traditional data warehouse, right? So you have a fixed hardware, software fixed to it, right? So it's very difficult to request the resources. For example, let's say you have a visualization tool connecting to the data warehouse, and you're running huge amount of queries, reports, dashboards, ad hoc queries, and all. So you need huge amount of resources there. So you cannot simply allocate the resources directly to the visualization part, right? Because it's all a queue-based system. So you have to wait for one queue to complete and then only can serve the another queue. So that's the elasticity. And high level, I mentioned like concurrent read and write. That is the challenge you have. So while you are writing, you cannot read it, otherwise it will be a dirty read kind of. And scalability, so you cannot scale up your data warehouse as easily, and you cannot scale down. Okay, I don't it's kind of a challenge again. And of course the cost is very expensive. You have to have upfront cost decided to buy the hardware and software, everything. And of course you have to invest more on the corresponding resources. When I say ETL, you need ETL admin, that is a cost, and database administration, database administrator, that is a cost. So that is again expensive. But some more challenges what I experienced personally is with my experiences in the projects and then deliverables. So these are the things I noted. These are looks high level, like deployment takes very longer time, right? So and agility is a biggest challenge. So you cannot handle unstructured data. Of course, storage and computing costs I covered. Administration with respect to technology I just mentioned. Sizing and tuning is a very tedious activity. So when you have huge volume of data sitting on a SQL Server database or Oracle, your indexes will grow, your storage will grow, your space will grow. It's hard to maintain indexes and all, and more indexes will be again a burden on the database. So you're actually hammering your database like anything. So that's again a challenge. And of course, the license costs, scaling and elasticity. Uh, One of the important things what I noticed is the downtime, so which is not acceptable for most of the customers, right? So you have, let's say, I was working for a retail customer, and when I say retail, it's like eBay, Amazon, or you can correlate. Um, you are running a business on, especially on holiday season, you cannot simply say to the customer, say, hey, I am running some maintenance on my database server, so I'll take a downtime of 1 hour or two. No. So it's a huge impact on the data, um, and the revenue of your the project or the business, and of course the brand name. So it's a huge setback for that particular major brand. If I say I am down for so and so hours during the peak Black Friday season or a Black Friday, so it's not acceptable. Another thing is the system security and potential data breach. They still have, even though the on-premise data warehouses have security and data protection, but still they lack when compared to the cloud. So that's the challenge what we have. Right. So let's look at the real-time scenario, what I'm trying to say, and you can correlate with the challenges of on-premise data warehouse, right? So you have on the left, okay, let's assume that, not exactly assume, this is the data warehouse system, which is on the center part. And you on your left, you have all the source systems, what we call in data warehouse terms, right? These are the source systems who feed data to me, to the data warehouse. And these are the end users who run analytics, reports, dashboards, and business team wants to see the live sales or something by running queries on data warehouse and marts. So when I say enterprise applications, we have various applications who feed the data and some third party tools like Google Cloud, where we have like a GA data, Google Analytics data. They supply some data here, and all your SEO, SEM related ads and ad details will be sent in the form of files, or you can directly access them through APIs. So those data set and web logs, all your events, for instance, the clickstream events, which you capture, all the user behavior activities on the website, they'll be in the form of logs, and you feed them into data warehouse. And the IoT, this is more and more, this is becoming a boom nowadays. I mean, of course, it is there from some time, quite a bit of some time, but still, eventually the data is going to grow. In a recent analysis, and one of the blogs, what I read is about 50 billion IoT devices will produce 80 zettabytes of data by 2025. So 80 zettabytes is 80,000 exabytes. You can imagine, like 2 to the power of 70. And imagine whether my data warehouse will be capable of handling such cases, such volume of data and such variety of data. It's a big challenge, right? So I talked about silos of diverse data from different devices growing rapidly. So what used to happen I mean, what still is happening in the traditional data warehouse is you cannot simply process a semi-structured data directly on data warehouse system, which is on SQL Server or Oracle. So you have to put that into Hadoop. You run that process. You kind of bring a meaningful data out of it into an Excel, I mean, a flat file, a CSV file, and then you feed that into a data warehouse and then put it in data marts, and eventually they will the end users will start using this. So imagine the amount of effort required to build this complex infrastructure and how costly it will be if you imagine the case of IoT data and weblogs data. So that's kind of a challenge when you when you look at high level, and to the person who is executing will be a real bottleneck for him. So I just mentioned few points here. It's kind of self-explanatory, or I can say. So you have your Hadoop, Cassandra, MongoDB. You have these systems like NoSQL database. You feed them the huge volume of data which is coming from clickstream or IoT, for say, which is complex, kind of require a new skill set and tools for a typical, let's say, SQL Server developer. You need to understand the Java and MapReduce programs, which is again, it is slow in terms of performance when you run analytics on top of it. Hadoop is very fast when you try to write it, but when you try to extract it, especially for OLAP, it is very slow, and it has its own limitations, and then it's kind of incomplete SQL. Um, it, there is a lack of enterprise controls when it comes to the security of these systems. And on the right hand side, you can see the legacy data warehousing. It's like, as I mentioned earlier, upfront capital costs and over provisioning, which is you have to code the codes, I mean, the price and everything for the hardware, software, and the resources. It's kind of huge, which is complex. As I said, when you have a huge volume of data in terms of terabyte itself is kind of difficult to have the partitions, indexes, and replication. And of course, it is not easy for migration. Like, it's not a lift and shift kind of migration. You have to take care of all the scenarios, all the cases when you try to migrate from a database to database, or a data warehouse to data warehouse, which is again on premise. So there are some use cases which are still unaddressed. So these are some which I noted down with my experience and then analysis. So it's still hard for a traditional data warehouse to have a combined structured and semi-structured data for reporting and analysis. So you have to have structured data, and then you have to have unstructured data in a different place, and you cannot build a relationship directly so that you can run a report on top of it, right? Uh, so that's a challenge. And exploratory and analytics is again a kind of tedious task. And then you cannot simply build a model out of this data set, right? So you have to break it, you have to bring it to a meaningful solution. Then it's again kind of tedious. Um, so you cannot simply eliminate a particular data mart, which is having a legacy data, for example, right? So you have to take into consideration a lot of things before you do that. So it's, as I said, it's not easy for lift and shift activities. Yeah, so we talked about all of the challenges and all the issues on everything for the traditional data warehouse. So what is the solution? How do we overcome it? How do we handle if my business grows? Let's say my data volume today is 1 GB, and let's say it goes up to exabyte, for example, right? So how do we handle that scenarios? So one thing I would like to call it as, maybe it is already invented, but I would like to still call it as reinvent, because we are reinventing to accommodate all those data sets and then bring it to a meaningful solution. So on the center side, you have this is actually a picture of snowflakes. Sorry for the color here, it's black. It's actually a blue completely. So you can run or build a data warehouse on top of this Snowflake Cloud Data Warehouse. Well, let's talk about Snowflake and cloud data warehousing in detail in the next slides, but just try to understand how we resolve these issues. So you build a cloud data warehouse on top of Snowflake. You can connect to your existing ETL tools, through JDBC, ODBC, and you have some direct native connectors. You can perform enterprise wide queries, and you can build your own solutions, analytics on top of it, and you can still use SQL because Snowflake provides that flexibility. So you can have big data on top of a Snowflake, meaning you have a variety of data sets coming from JSON files, Avro files, XML files, and still traditional flat files. So you can bring them in, and then you can build a solid relationship and then run a queries on top of it. So you can generate meaningful data set out of it. So what is all needed? So you put everything in cloud, which is very good in terms of elasticity and agility. So you can grow and shrink your data warehouse. We'll talk later why I said this sentence, and then you can understand better. So the bottom line is we build our data warehouse on cloud. We'll put all our data on cloud and build meaningful relationship and then meaningful data out of it while we extract it. And also you store the n number of data over the period of time based on the business needs again. Right. So let's talk about the cloud data warehouse, what exactly it is. So we spoke, okay, we'll put it in cloud and all actually. So what exactly it is? So as you can see from the definition itself, which is like huge cost upfront price will be reduced. So let's take an advantage of its capabilities while the cloud provider will take care of all its infrastructure, installation, configuration, software, hardware, everything. You just need to quote him. Okay, I need this. Okay, your configuration is done. You're ready to go. So let's take that advantage of removing the upfront costs and everything by utilizing this cloud data warehouse facilities. So as you can see, it is without huge upfront cost to purchase, install, and configure. That is to have required hardware and software and infrastructure. No, let's leave all these pain points, at least not to the full extent, but some extent pain points to the cloud provider. Right. So why we need a cloud data warehouse? So it's the biggest question mark, right? So one thing we talked about is how do we handle the huge volume of data which is coming out of IoT devices, right? So recently in Europe, you would have heard, so they in one of the major railway stations or subway stations, they introduced facial recognition. So the imagine amount of the data what we receive from them. And one of the, of course, in most of the United States cities, homes, they have a security system installed. So they usually monitor all the security features, and then imagine the amount of data that produces, right? So one of the best example is the smart homes in which is offered by Nest. So the you apply you put a device on your home, and it basically captures all the activities in and around your house, and if it will send out an alert to your local nearest cops and you as well if there is any unknown intruder or someone. So imagine it is for one house, and imagine the number of people who are using those devices across United States and across world. And imagine you are handling the data warehouse for those. I mean, you are the owner of Nest organization. So how do you handle in that case? So another classic example is DHL's tracking and monitoring system. The packaging and delivery solutions, so very popular in United States and across the world, of course. So imagine the challenges what they had with on-premises and how do they mitigated these challenges. Of course, so let's come to the point. So let's talk about customer experience, right? So you have a huge amount of data. Let's take the same example, DHL. So you call to the customer care executive and you ask, hey, where is my package? I have not received it, but I got an SMS saying today it will be delivered. So for the customer care executive to query the database and then get your exact information, it will take a huge amount of time. It is if it is on premise. If it is cloud, then it's real quick. So you have a better customer experience solved and handled in a much better way. And the quality assurance, of course, you deliver the quality data set. The operational efficiency, and you cannot simply wait for a, a petabyte of data to be loaded for weeks together, right? So if you want to run some analysis which is real quick, so you have to make sure that you load the data real quick and extract the data real quick. So that efficiency is covered here. And innovation, so you can run your innovations on very untouched areas. Actually, if you're having a sales organization, so if you want to see sales from, let's say, some there are anonymous customers and you want to see their buying pattern or purchasing pattern, so you can still do that using this cloud data set. Right. So before we start the Snowflake, let's talk about the cloud data warehouse offerings which are there in the market, right? For example, Microsoft provides Azure and Google provides Google Cloud, and we have Amazon's standard AWS Redshift built for analytics purpose. And why exactly we need Snowflake, we'll cover in the next slide, but we'll talk a bit about Snowflake definition and then we'll jump there. So these are the AWS, Google Cloud, and then your Azure are some of the cloud providers. I would not say they're the worst, might be their best, but better cloud solution is Snowflake, in my opinion. Why? Because we'll cover that in the next slide. Even though they provide a wide variety of offerings, they have certain limitations also. So having said about the cloud providers, let's talk about Snowflake. So what exactly is a Snowflake, right? Snowflake is a SaaS actually. It is a software as a service. When I say software as a service, so it covers everything. So you don't have to worry about hardware, you don't have to worry about software, and most importantly, my favorite part, the tuning. So you cannot simply spend a lot of time, to tune the database queries, indexes to get the performance out of it. Imagine if the data is in petabytes, zettabytes, it's a nightmare for a database administrator or a SQL developer or analyst to tune them, right? So it's kind of very difficult. So Snowflake is the one which takes care of everything, so you don't have to worry it. So you as I said, you configure it, you quote it, you build your data warehouse, and then just if you are having a native connectors for your ETL tool, and just plug in. And of course, Snowflake provides JDBC, ODBC connectors also for the visualization purpose. Your data warehouse is ready, right? So let's talk in detail about it. So why, I mean, what exactly is an elastic data warehouse and how Snowflake works, right? So you don't have to worry about legacy coding system or the legacy coding techniques or constraints which are there in the typical RDBMS scenario. And you can run on any cloud web services provider. Let's say in this case, Amazon Web Services as an example. You can host your Snowflake on Azure also, right? So that's the advantage, and that's why we have named it as designed for the cloud. And the third one is the delivered as a service. As I said, you don't have to worry about infrastructure, tuning, management, anything. So everything is taken care by Snowflake and all of your data. So you can deploy structured, semi-structured data at one place. This is really important, right? You can deploy, you can dump all your semi-structured and structured at one place. So this is a huge advantage we have here. So, and the more important thing is the question which pops up in my mind, like why Snowflake? Why I cannot go to Redshift? Let me give you a couple of disadvantages of using the Redshift, right? So why I cannot simply go to the Redshift, why I can rely on Snowflake, right? So when I say, of course, any cloud data warehouse is meant for massively parallel processing, right? So it all built on MPP architecture, right? So in the case of AWS, what happens? It supports only S3 and DynamoDB and Elastic MapReduce to run the parallel road, which is massive in SA. And other than that, you cannot use any of their services, right? So if you know about the Redshift, right? So it is built for analytics or analysis purpose, or a data warehouse, you can call it as. You cannot simply use that Redshift as your web app or application database. The reason is why, let's say you are connecting, you have a .NET application. I'm just giving an example. You have a .NET application connected to Redshift. So, and you have, let's say, SEM or SEO or anything, right? So basically you're searching. So the amount of requests that parallelly Redshift can handle is 120 queries or 120 threads, you can say, meaning there are only 15 queues allowed, and each queue can allow 8 threads concurrently. So altogether it is 120. Imagine if there are more number of customers hitting simultaneously, concurrently, whether it is in a position to handle, I don't think so. So you can imagine the case of classic IRCTC website, which is very famous railway booking website in India. The amount, there will be about 1 million bookings per day. In a day, there are 1 million bookings, and imagine the amount of concurrent hits on that particular database. Well, you have to have a full and concrete understanding of distributed key and sort keys, which are used for distributing the data across multiple nodes, across multiple caches, what we call. Without that, it's kind of hard if you decide to go with a particular set of distribution key and sort key, and you cannot simply change it unless you drop that table and then recreate with a new distribution and sort key. So these are some limitations what we have in Redshift. So these things are not there in Snowflakes. I mean, we can we cannot worry about the number of hits, concurrent reads and writes on the particular database. You don't have to worry about indexing, partitioning. And when I say MPP, it is real MPP. So you don't have a particular restriction as such. Most importantly, as mentioned in the slide, cost, which is relatively less because you have to pay only for what you use actually. So let's say you have a on-premise data warehouse, you took a license for 1 year, no matter what, you have to pay 1 year license cost. But here it is subscription-based model. So you can choose, okay, I need to run this data warehouse for 1 month, and later you can suspend it. And when the time comes where you need to run it again, so you can instantiate your data warehouse and then run the queries or process whatever, right? So in the silent period, what we call it, when the data is in rest or data warehouse is in rest, you don't have to pay anything. And the database features, right? It has a wide variety of database features available in Snowflake. So we'll talk one of the examples in next slides. And the maintenance in DevOps, as I said, you don't have to worry about hardware, software, and tuning. So we are good here. So let's take an example and try to understand how challenging big data to build a big data pipeline to analysts or technical team members or the business, right? So on the left hand side, oh, by the way, this is the traditional way of handling the or building the data warehouse. So you have your IoT devices, we have your web logs. I've just taken test 2 to showcase that, okay, we are really dealing with the big data, right? So when you feed all this information, you cannot directly feed into data warehouse because it cannot handle unstructured or semi-structured. So you have to put it in Hadoop, NoSQL, let's call it as Hadoop. So you have to do all the pre-processing here, and then you generate a CSV file, out of it, and then using native connectors to the data warehouse by using any ETL tool. In the case of Hadoop, it's a scoop command. I'm just going to give an example. You put that data into data warehouse and then expose that for the business users, right? So let's try to understand in detail a bit. What if JSON data is allowed you to fit that into data warehouse, and then how it works. So there is a example, a tweet example. I'm just taking some example. So there's a guy called Nagaraj and from Bangalore, some MSRIT college. So this is the JSON structure. And when you pre-process it and generate the CSV file, the format something looks like this. And then finally you put that into a data warehouse table, and this table will be exposed for the business team. So disadvantages, okay, let's take a step back. Disadvantages are, or I would say, an extra overhead or extra step involved here is you have to convert the JSON into CSV and then CSV to the database object. You have to map all these things. It's kind of an extra step, I would say. And any changes in the model, for example, if you change the structure or if you add more and more tags, then you have to change everything. You have to change the CSV structure, and then the table, the mapping you have to build in traditional data warehouse. It's kind of an extra step. So how do we mitigate that issue using the cloud solutions, right? So let's take the Snowflake as an example. The same thing, it is just replaced with Snowflake here. So same tweet example, and you directly feed into customer table. And in the previous slide, I was mentioning about DB feature, correct? So one of the data types that Snowflake provides is the variant data type, which will allow the JSON data to be, to sit in that particular data type defined on a particular column. So in this case, I've named it as tweet text. It's an example column, and the data is here, right? So, and then it is directly used for queries. Some sample queries I have given. So this is the query. If you look at closely, so you see tweet text, that is column dot object name, and again column dot object name city, and from the customer table it gives this data set. It's kind of easy, and the way it is stored is in the columnar format. Of course, I'm sure everybody are aware of what is row versus columnar storage. So I'll talk about a bit about row and column storage just before we move to the next slide, right? So let's finish this off, and then, right. So as I said, this particular object, let's treat this as an object for now. So name is mapped to the name column, and the column name can handle all the names in the database structure, and the city can hold all the cities in this, and college all the college details here, right? So let's not jump into the core technical details here. Let's high level understand what are the advantages, right? So we don't have an extra step to pre-process in Hadoop and generate CSV and then feed into data warehouse. No, so we can avoid that step. And any changes to the schema, so you can handle it. Let's say you have a new tag coming here, and you can very well fit in this here. So you don't have to alter anything here, right? And one of the most important thing here in the columnar storage is the optimization, right? So, okay, let me tell you a bit about the row storage and columnar storage. So let's take a classic example, a SQL Server and then a Redshift or a Snowflake for that matter. So in row storage, what happens? You put the record, and that same record structure will be there in the database storage or disk also. In the case of columns, um, the data will be stored in this format, in the column format, right? Customer ID will have only customer ID details. Timestamp will have only timestamp details, like that. So the compression is relatively low in the case of row-based structure, because you have variety of data types here. Let's say this is a varchar, this is varchar, this is varchar. Oh, let's look at this. Yeah, this is varchar, 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 and you have a timestamp data type here, and you have an integer or a big int data type here, right? So in the case of columnar storage, what happens? You have all the values for um, this particular customer ID column, which is integer, will be compressed, and which is easy to compress because it has most distinct data set. And when you compress this particular record, it is not that distinct, correct? Because it has different data types and different size also. So the compression, and then this is typically built for OLTP system, like record by record processing happens in OLTP. So you have to have that kind of structure, which is exclusively built for OLTP, I can say. And in the case of columnar storage, it is built for analytics. Let's say you run huge amount of aggregate functions on a huge amount of data, right? So you cannot, when you run the query on row-based system, it will, no matter if you select only two, it will select internally everything. And then it has to find the customer ID and name, for example. In the case of columnar, it will select only the customer ID and then say some sales amount here. So that's kind of advantages we have with the columnar storage. So I know I'm going really high, and then because I just want to give a brief structure about all these things, then we can jump into technical details more and more in the coming classes or sessions, right? So let's look at the architecture of Snowflake. So why we have a brand name, or why we called it as a brand new architecture? So personally, I feel this is a brand new architecture because it is having multi-cluster and shared data architecture, which is kind of impossible. I would not say impossible, little challenging in the case of on-premise data warehouse, right? So where we have a share nothing architecture, and it is decentralized, meaning you cannot combine everything at a central place. All the data you cannot maintain at a centralized location. So, and it is having a single cluster. So it has its own node and it has its own storage attached to it, like that. Where in the case of Snowflake, what happens, you have multi-cluster and shared data architecture. So you cannot, you can read and write concurrently, right? Let's say your development team and testing team is trying to write the data, and simultaneously your analysts can read that particular data, right? So of course, in the case of production environment, you cannot do a development kind of activity, but let's assume that you are loading the data continuously in production environment, and simultaneously your analysts and the sales team is trying to fetch that data to see the sales numbers and the trends. So this is possible. And scale out storage is very helpful feature in the Snowflake architecture, because you can scale out without any issues, without having a downtime, and without relying on any other external sources, dependencies. So you can scale out as easily as possible. And you have multiple clusters, and you cannot simply say I can put compute and storage in one place. No, you can differentiate, and then you can allow the compute for one node or cluster, and storage for one node or cluster. You can segregate between compute and storage. So that feature is there in the Snowflake. So that's the reason it is very helpful for concurrent reads and writes in Snowflake. So I spoke about multi-cluster shared data architecture. Let's go a bit more detail and then try to understand what it is. So this the lighter green or a lighter blue, sorry. So I would say this is a centralized storage unit where we can have your sales data, with your revenue data, you have your products information, you have your customer details, everything at a centralized storage unit. And you have different compute units attached to it. So it is thick blue, or this is dark blue, let's call it as. Sorry for that. So we have different compute units attached to it. One unit can handle the loading part, and simultaneously one unit can run some queries and some for some analytics purpose, and one unit can very well develop their code and then very well add their code to the existing environment. And simultaneously we have different services here, right? So you have optimization techniques we can handle simultaneously. We have better management. You have transactions, concurrent transactions, no locks as such. We have wide variety of security. This has a huge and very good security model. If you heard about AES 256 encryption, that is the security feature it provides. And of course, it follows all the auditing features like SOC 2, HIPAA, etc. So we'll talk about it later. So this is the high level architecture, right? About multi-structured and shared data. Shared data architecture is a very good and interesting. Personally, I feel very interesting because everybody are interested to, nowadays people are prefer to have faster data analytics and faster data access, faster data load. So if you have the shared data architecture environment, so you don't have to wait for one person to complete his transactions or activities. So you can very well use simultaneously. So when you go deeper into the technical details, we will actually show you how you can leverage this skill or the feature. Right. So it has very, very strong concurrency. I talked about it multiple times. You have with wide variety of features it has. So you don't have to have multiple services here. It's just a single service which can handle all these features, and it has a centralized storage which is automatic, scalable, and instant. So you don't have to wait, worry about disaster or something like very worse scenarios like that. So we have elasticity, scalable compute. It's like multiple virtual warehouse compute clusters, which will help for concurrent read and write. So as I mentioned in the previous slide, you can one set of team members can do a loading, and simultaneously other can run the queries. Right. So I I briefly discussed about the difference about the other cloud services like Redshift and then why Snowflake. Um, as you can see, one of the or these are the key things what I noticed personally with respect to Snowflake, right? So it is 200% faster and at very minimal cost actually. So you since you have a compute and storage units separated, so you don't have to pay for anything which is interdependent. I mean, storage is not dependent on compute. Storage is different, storage cost is different, compute cost is different. So then since that is the case and it is relatively faster, so you can load n number of petabytes of data in a less time, very less time, I would say. So concurrency, which is I marked it as a happy symbol because of course multiple groups can access simultaneously without a lock or holding back a particular object, a table, something like that. And it is very simple. As you can see in the coming slides, I'll show you how to configure it and then use it. It is relatively simple. So it's a fully pay as you go model, and then works with any data structure as I highlighted. Relatively simple to use, and you don't need extra education, at least with respect to configuring and then something, of course, unless you have some technical background of why we need it, what exactly we need. So you don't have to rely on a particular skill set as such, since it is simple. Um, let's we talked about it multiple times, like no hardware, no infrastructure management, no storage management, no metadata management, which is a tedious task in terms of performance and avoiding any data duplicacy, something like that, especially when you are managing the metadata. And manual query optimization, you don't have to say the developers, okay, use not exist in place of in, or in exist, not exist in any such kind of scenarios, and you don't have to tell them you use query in this fashion or something. But of course you have to follow some standards, but you don't have to worry too much on optimization. Right, so why this is a best fit, why we called it as a best fit, because you have very diverse data structures or diverse data sources which are coming from traditional systems, big data, IoT, and you have wide variety of connectors available for your data processing, for ETL, you have Informatica, SnapLogic, Talent, Matillion, Alteryx, etc. And you can concurrently use for reporting using Tableau, MicroStrategy, and analytics purpose by running R or Python, something like that. So it covers everything. I would say this is kind of a package for your ecosystem, which is a best in my opinion. That's why I called it as best fit for your ecosystem. And of course, let's come to the core standards and security policies. Here we have authentication, we have multi-factor authentication, we have federated authentication here. We have wide variety of access control. You can have role-based access control, and you can have a granular-based. For example, you can have a certain number of people to access a few tables or few columns out of it. And encryption, I already mentioned, this is AES 256 encrypted, so it is highly secured. And for any what you call auditing purpose, you have SOC 2, HIPAA. Those things are already covered as part of security and data protection features here. So we talked so many things about data warehouse, cloud data warehouse, Snowflake. Let's look at the use cases or business scenarios, how they resolved it by taking help of Snowflake, right? I'm sure everybody are aware of ask.com. It's like any other search engine. So they had a challenge, they were not able to process a huge amount of JSON data and then put it in a centralized place for their analysis, and then touch the insights, get the meaningful data and for prediction, etc. So they were not having any particular development or test environment, right? And the performance when accessing the data, when analyzing data, was really a challenge. So the current system or current infrastructure, what they have is 100 node Hadoop cluster and 36 data warehouses, and which is like you get the JSON data from different websites like Ask, About, Investopedia, Dictionary. So when you have all the data sources which bombard your database and data warehouse with huge data volume, it's really hard to maintain and then analyze that data. So how Snowflake helped them? So the one best solution they provided is you load all the data at one shot, so you don't have to load data in chunks. For example, let's say, so you get data from about.com, you load first and then occupied, then second, third, dictionary, nothing like that. You load everything at one shot, right? So you load data from different uh, formats, right? And then you explore it and you build the test cases, and then you build a new algorithms on top of it. And you have very good native connectors for Snowflake. So you don't have to worry about connecting to Snowflake and run your analytics and view your data set, or for example, reports or dashboards. Um, and one another good feature, it has a cloning. You can clone entire data warehouse, and then you can make them as dev or test environment. So Snowflake provided this feature. So with this help, they were able to build the dev and test environment without any extra trouble or extra hurdle. So finally, the director quoted this: because of Snowflake, business intelligence is moving from a cost center to a value center. This is a huge, major win or a success for them to resolve this kind of scenario. And another scenario is for fraud detection. I'm sure you heard about white ops. They had, again, the huge volume of JSON data set. They wanted to have the exploration and analysis, right? They want to see how many frauds have been done, how many fraud cases have been registered, what are the actions taken out of it, and then such kind of scenarios, typically what fraud detectors do. So the challenge to load that particular data and then run the analytics on top of it was again a nightmare for them. So as you can see, the Snowflake provided resolved this issue without any extra step or something, and then they helped them to speed up their algorithms from 24 hours to 2 hours. So let's say I want to see a particular fraud case in this particular county, in a particular state, then it was to take a lot of time. They helped them to resolve this issue. So the comment you can see, the Snowflake enables us to unlock large data sets to make it possible for business analysts. So this is kind of huge wins for large organizations. As you can see, the customers, it has got wide variety of customers from all the different domains. I would say retail, healthcare, anything, right? So you can maybe you can look at it closely. So this is just a sample list of customers have taken. There are even more wider customers than this, which make use of Snowflake, to take its advantages and then have a peaceful business and then get more data insights, get more business, and get more revenue out of it. Right. In summary, so what exactly is a Snowflake? So it's a brand new data warehouse exclusively built for cloud data warehouse solutions. You can combine structured, unstructured data in an optimized way. And what exactly the Snowflake delivers is one-stop storage, diverse data, easier and faster analytics, cost-effective solutions, and then it's a better alternative for complex approaches. That's the advantage of having Snowflake in place. So having said that, I truly apologize if I took more time to explain about the system. Let's open the Q&A session.
Uh, do we really need to understand about the JSON format and all, or any other? Do we need to know about
I'm
any database sorry, not database languages or any
I'm
programming
sorry.
languages to work on the Snowflake database?
I truly apologize. I think you're breaking up. I did not hear the question at all. So can you repeat it?
Uh, yeah. Do we really need to know about the JSON format or any programming languages to work on the Snowflake database?
Not really. You don't have to know complete architecture or any programming language as such, but it's good to have a knowledge on how the JSON object looks, because you have to configure your JSON object on Snowflake accordingly. So you have to have some knowledge about JSON files and its architecture. And when we talk about programming languages, if I understood correctly, you're talking about Python or shell scripting. Well, there are cases when people really do not want to invest more on buying ETL for data processing, um, right? So most in one of my projects actually, so customer preferred to have Python in place. So to build a Python code, you have to have some knowledge of Python scripts. It is good to have, so you can avoid the dependency on another resource who is good at Python or shell.
So basically, just if you know this, if you have a database knowledge, that is more than enough, I believe.
Yes, the minimum requirement is you have to have database knowledge, at least one database, SQL Server, Oracle, or Redshift for that matter. And if you know how the data warehouse system works, because you have to know the relationship, what is dimension fact, how the model works. So that's well and good. So you have to have some knowledge of data warehouse, and mandatory is database. So you're right.
Hi Raja, this is Naresh. Thanks for
I
the
said,
session. I have a question. Like I read somewhere that Snowflake is a time travel options. Like we can retrieve the data before one day, how the table looks like how the data was before one day. So is it true?
that's exactly true. I thought of explaining that in the coming sessions, but I'll give you an example, right? So let's say accidentally you drop a table, right, from any SQL Server database, unless you restore the database in case of SQL Server, right? You restore the database or restore with your old backup file, you will lose your table data. Again, I mean, restoring the table, it's not a easy. I mean, restoring the database or a backup file is not a easy, and then quite a people will not agree for that, right? So in Snowflake case, we have a simple command for that. Is you just have to type undrop and your table will be back. So you don't have to worry about restoring um, restoring your database with the old backup file or something. Yep, it's very true that time travel option is very well good in Snowflake.
Thanks, Raja.
Any other questions for me? Any?
Hi Rakesh, Srikanth here.
Hello,
Uh,
Srikanth.
yeah, I just saw the challenge in your slide, like ETL license first. So on one more slide, you have mentioned like you are going to connect to the Informatica server, Informatica with Snowflake. So you mean to say that is the ELT or ETL license first?
I'm sorry, I missed the point.
In your challenges, you have mentioned like ETL license first. There is no ETL license first. You mentioned, right?
Right, right,
And one more slide, I have seen that we are going to connect to Snowflake by using Informatica or any other ETL tools.
right.
So, so you mean to say that is ELT in earlier slide, or it is ETL? There is no without the connection to ETL, we can using directly use Snowflake.
No, a Snowflake has got its native connectors, right? So you can, of course, okay, one more point is in Snowflake or any cloud data warehouse, what happens, it's typically an ELT. It cannot be a ETL. So you don't have to worry about transformations or anything upfront. So you dump the data on Snowflake and then you do a transformation later. So in the case of ETL licenses, right? So you um, if you have a subscription based model, let's say I will take the license for only 6 months, then you don't have to pay upfront cost for 1 year.
Okay. So, and one more thing is, does it having like compression techniques and partition techniques?
Yes, of course. That's a very good question. So uh, let's say you have decided to host your Snowflake on AWS, right? So AWS will take care of compression and partitioning techniques. So if you heard about LZO algorithms and all, so that is one of the best algorithm which is used to compress the data. And the advantage with using Snowflake is, so you have to pay your storage cost on the compressed data set. You don't have to pay the data the cost for the whole data set. So of course it has its own algorithm methods. LZO is in one example.
So you mean to say that this is the combination of a database and ETL?
I'm sorry, I didn't understand the context here.
So you mean to say that the Snowflake is the combination of a database and ETL
uh,
and data warehouse.
it's not exactly ETL. It is, I would say, it is ELT because you have to worry about bringing your data on Snowflake, and you don't have to worry about transformations and all, right? I'll try to give an example here. So the transformations, most of the time, what happens, it takes a lot of time and it takes a lot of cache memory while doing the transformation in the case of on-premise data warehouse. Let's say you have uh, your ETL tool Informatica and you have your target data warehouse as Oracle or SQL Server. So it takes its own cache to do all the transformation and then try to load it, right? So in this case, what happens, you worry about dumping the data on me on Snowflake. So I will take care of transformation thing, and you don't have to worry about memory having extra space on the server. All these things can be avoided. And as you said, it is a data warehouse with a combination of analytics database, that is true database, plus ELT feature.
Okay, got it. Thank you.
Well, for the compression questions, I think Srikanth asked this. I can get you more and more compression details, and then I can really show you uh, the different compression methods, algorithm it internally uses, and then how much size it becomes after reducing it. Because typically what happens in the case of RDBMS, right, the SQL Server, when you take the backup and then when you compress it, of course, when you take the backup of if you heard about master data file and secondary data file, so all the master data file, it is in compressed format, but it is a row-wise compressed format. And in the case of Snowflake, it is columnar storage. It is compressed based on columns. And the better compression algorithms are used in Snowflake when compared to RDBMS or traditional database. Sorry, I mean, I have to tell this because this is one of the important, and interesting thing for me in terms of cost and then, learning how it works.
Yeah, it's true. I agree.
Raj, if you don't mind, can you just brief like different types of tables available in Snowflake?
Different types of tables. You're talking about system tables?
Yeah, we have like transient and one is the persistent, some and temporary and permanent.
Right, right. So we have, oh, okay. I think it is kind of a huge topic, I would say. I need some time to tell you and explain how these things work actually. We have internal and external table concept here, and then we have transient table concept here, and then we have different tables, and then we have metadata tables exclusively meant for Snowflake. Uh, I would like to take in a different session, Suresh, if I'm sorry, I cannot uh, explain everything you
It's
in,
not.
one session.
Yeah, yeah, no problem, Raj. Thanks.
Yeah, because it's as a true data guy, right? I'm a data enthusiast, so I would like to tell you more technically practically than theoretically, right? Because that will help for me to understand and learn more, and also I'll try to help you to understand, if not 100%, at least 10%. That's my intention,
Yeah,
right? I hope
thanks very much.
yeah.
Hey, Naresh, could you please, I have pinged you in the messenger, in the chat box. Could you please respond back?